Let's look at multidimensional arrays. What we've seen in previous videos are just one-dimensional arrays that we see here again on the slide. So an array is basically, as we've seen, a collection of data items. Here you see it on the slide. This is an array that has 8 elements in it, and they're stored going from 0 to 7, where you have 8 positions to store the numbers that you see here in this blue array. So we have seen that you can have homogeneous arrays where all the elements that are stored in the array have the same type. You can have heterogeneous arrays where all the elements that are stored in the array have different types. And we have also seen how we can access these elements in the array by just calling the name of the array and indicating the position of the element that we want to access. Here we see again the same example. C, which is the name of the array, at position 5 has value -89. So we have seen arrays in the context of object-oriented programming paradigm, but arrays can be used in all programming paradigms. The same is for all the other data structures that we're going to see in coming videos, like linked lists, stacks, and queues. These are all data structures that are used in all programming paradigms. So the one thing that we want to stress in this video is that arrays do not only have to be one-dimensional as on this slide, but they can be multi-dimensional, and this actually gives them more power. So let's look at an example here. This is a two-dimensional array which has rows and also columns. So we can have several dimensions here to store more data. And the data is accessed as the one-dimensional arrays, where we just indicate the position of the index that we want to access. So I mentioned here that we start counting again at 0. Then with dimension 2, we have here 948 at position 1, 2. This is 0, 1, 2, and this is 0, 1. So 1, 0, 1, 2, 1, 2. So with 2 dimensions, as we can see here on the slide, these arrays look like a table. If we add 1 dimension more, they will be like a cube of data. And we can add more dimensions if we want, but then we don't really have a spatial representation anymore beyond cubes.